In this video, I'm going to look at a review of derivatives which you have probably covered at A level or at undergraduate level. A derivative is the instantaneous rate of change of a function. Derivatives help us to understand how model predictions change with respect to input features, providing insights into model sensitivity. For single variable calculus, we are saying the functions that we are looking at are functions of one variable only. For functions of many variables, we'll look at it in another lecture. So now go on and look at the notation that we'll be using. For our functions, we can write y is equals to f of x. And for the derivative of the y, we write it as dy dx. Or in short, we write it as f prime of x. So that's the notation that we would use. If we are given a function, then the derivative we denote it by dy dx or f prime of x. The next thing that we need to look at are the common derivative rules. So for the common derivative rules, the first one that we'll look at is the power rule. The power rule says that the derivative with respect to x of x to the power n is equals to n multiplied by x to the power n minus 1. So let us just look at an example. If we are given a function y is equals to x to the power 5, we see that in this case, the x is raised to the power 5, so our n is a 5. So if we substitute 5 into this formula here, we would have that the derivative of y with respect to x is equals to 5 multiplied by x to the power 5 minus 1. And the 5 minus 1 gives us a 4, so that our expression becomes 5 multiplied by x to the power 4. I now move on to the next rule when you are looking at a constant function. If c is a real number, then the derivative of c with respect to x is equals to 0. For example, if we have our function y is equals to 3, the 3 there is a constant. So by this rule here, which says that the derivative of a constant is equals to 0, we have that the derivative of y with respect to x is equals to 0. I now move on to the next one. When you are looking at a constant multiple of a function, if c is a real number, the derivative with respect to x of c multiplied by a function f of x is equals to c multiplied by f prime of x. For example, if we have the function y is equals to 5x cubed, we are having a constant 5 multiplying a function x cubed. So we'll be saying that our c in this case is the 5, then our f of x is x cubed. So using this formula here, the derivative of y with respect to x will be 5 multiplied by the derivative of x cubed with respect to x. Now when we are looking at this part here, the derivative of x cubed with respect to x, we evaluate it by using the power rule, which says that the derivative of x to the power n is equals to n multiplied by x to the power n minus 1. In this case, our n is a 3, so we have 3 minus 1 will give us a 2, so our expression becomes 5 multiplied by 3x squared. And 5 times 3 gives us a 15, so our result is 15x squared. I now go on to the next rule, or the sum rule. For the sum rule, if we have functions f and g which are differentiable, then the derivative with respect to x of f of x plus or minus g of x is equals to the derivative with respect to x of f of x plus or minus the derivative of g of x with respect to x. So when you are differentiating a sum, we just add the derivatives. When you are differentiating a difference, we just subtract the derivatives there. So for example, if we have a function y is equals to x to the power 5 plus x to the power 3, we are having two functions there, x to the power 5 being added to x to the power 3. So by this rule, we just add the 2 when we differentiate. So the derivative of y with respect to x will be the derivative of x to the power 5 with respect to x plus the derivative of x cubed with respect to x. Now looking at this part here and this part here, we evaluate them using the power rule, which says that the derivative of x to the power n is equals to n multiplied by x to the power n minus 1. So for the first one here, our n is a 5, so we'd have 5 multiplied by x to the power 5 minus 1. For the second one here, we'll be having our n is 3, so we'll be having 3 multiplied by x to the power 3 minus 1. So our result becomes 5x to the power 4 plus 3x squared. I now move on to the next rule, which is the product rule. If f and g are differentiable functions, then the derivative with respect to x of f of x multiplied by g of x is equals to f prime of x multiplied by g of x plus f of x multiplied by g prime of x. For example, if we have a function y is equals to 7x plus 1 multiplied by x to the power 4 minus x cubed. Looking at this function that we are given, if we look at this part here, we can call it our f of x, and then this part here, we call it our g of x. So we have two functions there multiplying each other, f of x and g of x. So using this formula here, our derivative of y with respect to x becomes the derivative with respect to x of 7x plus 1 multiplied by x to the power 4 minus x to the power 3. And then for the second part, we'll now be looking at the f of x multiplied by g prime of x. And it will give us plus 7x plus 1 multiplied by the derivative with respect to x of x to the power 4 minus x to the power 3. We then go on and look at this part here, the derivative of 7x plus 1. The derivative of 7x plus 1 gives us a 7. So we just remain with the 7 multiplying this part here. So we have 7 multiplied by x to the power 4 minus x to the power 3. Now go on and look at this derivative here, x to the power 4 minus x to the power 3. We use the power rule there. It will give us 4x cubed minus 3x squared. So our expression becomes plus 7x plus 1 multiplied by 4x to the power 3 minus 3x squared. So that's our derivative there using the product rule. I now go on to the next rule, which is the quotient rule. It says that if f and g are differentiable functions and g of x is not equal to 0, and then the derivative of the quotient f of x divided by g of x is equals to g of x multiplied by f prime of x minus f of x multiplied by g prime of x divided by g of x squared. So for example, if we are looking at the function y is equals to 10 divided by x squared plus 1. In this case, if we look at our numerator there, we are having a 10. So that's what we call our f of x. And our denominator there is the x squared plus 1. That's what we call our g of x. So in our formula here, we start by differentiating the f of x to get f prime. And we have our f prime of x is equals to 0 since the f of x is a constant. And then differentiate the g and we get a g prime is equals to 2x. And then substitute this into this formula here. And then we have the derivative of y with respect to x is equals to x squared plus 1 multiplied by 0 minus 10 times 2x divided by x squared plus 1 squared. On this part here, x squared plus 1 multiplied by 0 is just a 0. So in the numerator, we remain with minus 20x. So we have our result there is minus 20x divided by x squared plus 1 squared. I now move on to the next rule, which is the power rule for functions. If m is an integer and g is a differentiable function, then the derivative of a g of x to the power n with respect to x is equals to n multiplied by g of x to the power n minus 1 multiplied by g prime of x. So for example, if we have a function y is equals to 4x to the power 100. 100 here is an integer, so we can use the power rule for functions here. So if we look at this part here, the 4x, and that's our g of x, and the power there, the 100, that's our n. So in our formula, we have a g prime of x there, so we have to differentiate this g of x that we have here. So the derivative of 4x gives us a 4. So we have our g prime is equals to 4. And our n minus 1 is 100 minus 1, which gives us a 99. So substitute these values into our formula here, and then we have the derivative of y with respect to x is equals to 100 multiplied by 4x to the power 99 multiplied by 4. And then multiply this 4 by this 100 and you get a 400. So our expression becomes 400 multiplied by 4x to the power 99. So that's the derivative there using the power rule for functions.